Okay, now this is the graph of sine theta, y equals sine theta. I've put in most of the values there, all right? But if you went into your calculator and you did sine of 10 degrees, 20, etc., these are the values that you would get to 2 decimal places. I've just missed out a few. Sine of 0, anyone know? Could you, if you go to your calculator, sine of 0 is 0. Sine of 90, please do some on your calc. Sine of 90 is 1. Sine of 180, 0. Just try them. Sine of 270. Go, go, go. Yep, and sine of 360. So, sine of 0 is 0. Sine of 90 is 1. Sine of 180 is 0. Sine of 270 is -1. Sine of 360 is 0. I'll put a theta there, and this is y. Sine of 0 is 0. So this is my sine curve. Now, you know between 0 and 90 degrees, isn't that quadrant 1? And all the sine of any angle between 0 and 90 degrees is positive. Look at all stations to central. In quadrant 2, isn't sine positive? Quadrant 2 are obtuse angles between 90 and 180. So, here we go. We've got 0, 90, 180. This is quadrant 1, quadrant 2. So sine, we know we've got all stations to central. Sine is positive in quadrant 1 and 2, but you can see it here. Sine of 100, 110, etc., all the way up to 180. They're all positive, except 180 is 0. So, see how the values are still positive when theta is 150? The y value is still positive. Do you see it? So the graph, so the sine graph, girls, is like a roller coaster. Starting in the middle, going up, down, that's quadrant 1, quadrant 2. You know how sine is negative in quadrants 3 and 4? Look at these values of theta, how they're negative. Do you see that? Quadrant 3 and quadrant 4. You okay with that so far? So this is the sine curve. So whenever you think of sine curve, this is what you do. You do the roller coaster. Starting at the middle, up, and it's a full wave. And then you go, well, it's 360 degrees for one complete period. It's called a period. So obviously halfway is 180, 90, 270. We got it? Up, down, up, down, up. So it's a wave. Sine 1 starts in the middle. How are you going to remember that? Well, you just get your calculator out and you do sine 0. And if it's 0, yep, that's the one that starts in the middle. Up, down, etc. You can try your 0, 90. But now if you just know that shape, that's where it starts. You do one full curve every 360 degrees. One full up and down roller coaster. All right, look how sine 30, for example, is a half. That's not negative, it's just the graph. And sine 150 is also a half. Notice we get the same values for a number of things. The other thing is sine 60, for example, here is 0.87, and so is sine 120. Now, this is what we're going to be doing, noticing these things. They're called the related angles. There are certain, you know, look here, sine of 210 is negative a half, but so is sine of 330. It's also negative a half. Look. Can you see that? All right, now. All right, so quadrant 1, quadrant 2, positive, positive, negative, negative. Fits in with all stations to central. So, now we can see the maximum value and the minimum value for sine theta. The values go between, 1 is the maximum value. What's the minimum value? -1. So when you draw the curve, and you learn how to draw it like that, again, we go like this. That's our curve. Just practice drawing it. 180. 360. I like to do, draw it, and then I go 1, -1, and I put 360 first, and then obviously halfway is 180. So you tell me the maximum value for sine theta is, it's the maximum y value, it's 1, and the minimum value is -1. And sine theta equals 0 when theta is 0, what else? 180 and 360, all in degrees. And sine theta is 1 when theta is what? 90 degrees. And it's -1 when it's 270. Good. Okay, we can see from the graph as well that sine theta is positive in quadrants 1 and 2. Fits in with all stations to central. And it's negative in quadrants 3 and 4. Now, just looking at our graph, if I told you that sine theta was a half, we're going to do these properly later. We're just observing at the moment. If sine theta is a half, there are two values on your graph that give you a half. What are they? So sine theta is a half. What are the values for theta? 30 and 150. All right, so 30 and 150. And if sine theta is negative a half, which is down here, what are your values? 210 and 330. I'm going to show you something about this in a minute. Just watch. 30. If I put 30 here, isn't that 150? Right. You know how I talked about the butterfly? Butterfly is important. Look. Watch. So I've got, look, quadrant 1, 30, yeah? Quadrant 2, 150. Can you see that? If I leave 30 out. Quadrant 3, isn't it 180 plus 30? And quadrant 4, isn't it 360 minus 30? See how all those 30s in the butterfly give me all the same half, but some are positive and some are negative? So which ones are positive? Quadrant 1 and 2. So if I do, so in quadrant 1, if I have a 30-degree angle that touches the x-axis, sine 30 is a half. Now, in quadrant 2, if I'm in quadrant 2 and I put a 30 here, that sine of 150 is also a half. So quadrant 2, the 30-degree angle that touches the x-axis, that's 150 over there. Now that happens to be 180 minus 30. Okay? Now that actually happens to be the same as sine 30. Gives me the same answer. So isn't sine 150 the same as sine 30? Gives me the same answer. But look at quadrant 3. So sine of 210 is negative a half. But if I look at quadrant 3 with a 30-degree angle there, how does that get formed? Isn't it 180 plus 30? I'm going to write something here in a minute. And quadrant 4, if I've got a 30-degree angle in there, that angle going all the way round, sine 330 we know from our graph was negative a half, but sine 330 is sine of 360 minus 30. You know, like it's 360 minus theta, all right? So that's 330 around there. Now that's 210 around there. Now, you know how sine of 210 is negative a half? It's almost the same answer as sine 30. It's like the sine 30 answer with a negative in front of it. So girls, if you're at 210, you draw where 210 is, but you're not interested in the 210 anymore. You're interested in the butterfly angle, the acute angle in that quadrant, and it's 30. So I say, yeah, I know that sine 210 is the same as sine 30, but because I'm now in quadrant 3, the sine angle is negative, so I have to put a negative in front of it. So sine 210 is the same as negative sine 30. Because sine of 30 is a half, but sine of 210 is negative a half. Yes, no? All right, if I'm talking about sine 330, I do my 330 around, I've got an acute angle of 30 left. So sine 330 is related to sine 30, but because I'm in quadrant 4, I know that sine of 330 will be negative, so it's negative sine 30. Because always the acute angle is positive. Sine 30 is positive. I know that sine 330 is negative, so this is what the theta is. Sorry. No, that's what sine 330 is. It's the same as negative sine 30. Look, I'll explain this again later, properly. Well, just differently. A bit more concisely. Does not go on forever and ever. I mean, it does, actually. Sorry, it does. It doesn't just go from 0 to 360. There's 1 period, 2 periods. It repeats every 360 degrees. And we're also going to be looking at negative angles next lesson and how to draw them as well. So then it can go backwards, negative 180, negative 360. Okay, so the graph of sine theta repeats every 360 degrees. We say that the graph of sine theta has a period of 360 degrees. And look, this was from last year. Would you say that's got line? You know about symmetry. What sort of symmetry is that? It doesn't have, the axis of symmetry is not there, but it does have a symmetry about the origin. Do you know what it is? It's point symmetry. It's got, so it's got point symmetry about the origin. So what we're saying is that if you look at this point up here and reflect that point here through the origin, it appears on the other side. Look here, if you're that distance across there and come through the origin, you've got a matching point on the other side. Look, from here, if you put a ruler and measured from there to there but kept going, that point matches up there. So that's called point symmetry. Okay? All right, now, again, oh good, this is what we're going to do here now. This is what I was talking about before. Okay. Good. All right, remember we had all these values before where we've got sine 0 is 0, sine 90 is 1, then we've got 0, negative 1, and 0. All right, sine of 100. Just think. I'm going to draw where 100 would, so I'm just going to draw this. Girls, if 100 would be here, wouldn't it? I'm not interested in the 100. What am I interested in? 100 would be like that. If that's 100, what's this angle here? 80. So if theta sine of, you have to think of the 100 as being 180 minus what, okay? Look, you can learn the rule, but I prefer to think of it as 100 is here. What's this angle? 80. Look, 140 is there. What's the leftover little angle? 40. Now, because sine is positive in quadrant 2, we just say sine of 140 is the same as sine 40. Sine of 110. If 110 is here, what's over here, girls? 70. You see what I'm doing? Sine of 150. I'm drawing these on purpose because you need to know sine 150 and how to draw it. I'm not interested in the obtuse angle. What's the related acute angle, the one that touches the x-axis? It's 30, and it's positive because sine is positive in quadrant 2. Sine of 130, do you know what it would be? If that's 130, this would be 50. And sine of 160, just draw a couple of them like that. And what would be the related acute angle? 20. Okay, so that's quadrant 2. Sine is positive in quadrants 1 and 2, meaning it's positive from 0 to 180. Now, quadrant 3, 190 is 180 and how much more? 10 more. So it's the same as sine 10. Oh dear, I should have left. So girls, can you put, sorry, it's going to be negative sine 10 but because I'm in quadrant 3 now and sine of 190 is negative. So it's the same value as negative sine 10. Now look at the table I've given you. Sine of 190 is negative 0.17. Isn't that the same as sine 10 with a negative in front of it? All right. Sine of 230. Where's 230? So that was my 190, which is 10 degrees over. 230 is 180 plus how many degrees over? 230. Come on. No. 50? So sine of 230 is the same as negative sine 50. Are you okay with that? So what you do is you draw the 230 and you can see it goes over into quadrant 3 by 50 degrees. Because we're talking about sine and we're in quadrant 3, the answer is negative. All right, sine of 200. How many degrees over? And I'm interested in the little 20. But it's negative. So sine of 200 is the same as negative sine 20. Good. Keep going. 240 is how many degrees over? Just draw a couple of them. It's important because that one goes 60 over. So look at your table as well. Sine of 240 is the same as negative of sine 60. You can see it in the table as well. Sine 220. 220 is how many degrees over? 40 degrees over. So sine of 220, please put the negative in front. It's negative sine 40. And sine of 260, yeah. So 260 will be down there. The little angle in there is 60. It's 80, sorry. It's the same as negative sine 80. Because you think of the 260 as being 180 plus 80 more. Do you get the idea of this? Now, in quadrant 4, same thing. Sine of 360 minus theta. But I just prefer to draw it instead of learning the rule. So 280 would be here. Because, you know, you've got 0, 90, 180, 270. It's going to be the same as, what's the, that's 280. What's left over to make the full revolution? No. Remember, it's the butterfly. I'm interested in what's there. You got it? So it's negative sine 80. Sine of 320. 320 would be all the way around to there. Be careful. 320's there. What's left over to make a full circle? So we're in quadrant 4, so your answer is negative sine 40. Okay. Sine of 290. Well, 290 is there. And you've got 70 left over. It's negative sine 70. And keep going. Short how much? Short by 30. So it's negative sine 30. Sine of 300 is short by 60 degrees. It's the same, and we're quadrant 4, so it's negative sine 60. And sine of 350 is short by 10 degrees. So it's negative sine 10 degrees. All good?